Okay, so Newton's second law is the law of acceleration. And the way we remember that is force equals mass times acceleration. So what that means is a force is needed to change motion. And what you guys need to understand about acceleration, it doesn't just mean speed up. Acceleration means a change in motion. So you can accelerate by speeding up, slowing down, or changing direction. All of those are accelerate. Okay? So start thinking about accelerate in terms of changing motion. Acceleration is a change in motion. Objects accelerate in the direction of the force. The more force that is applied, the greater acceleration, and the more mass an object has, the more force is needed to accelerate the object. So again, think about a car. To get that car to move just a little bit, that's accelerating. To get the car to move just a little bit, you need a lot of force compared to a bike. To get a bike to accelerate, you could just push it with one hand and the bike will move. Okay? So we'll look at it this way. If using more force, there will be more acceleration, which is a change in motion. If you barely touch something, you might not see that much of a change in its motion. So the acceleration of this loaded cart will increase when a larger force is exerted on it. So he's barely pushing the cart and the cart is barely moving. But when he applies a lot more force to the cart, he gets a lot more acceleration. So more force, there will be more acceleration if mass is constant. Okay, that's really important. If mass is staying the same. So for this example, the mass of the cart is the same in each trial. What he changed was the force, and he saw a greater acceleration when he increased the force. When we apply mass, when mass is not constant, the more mass, the less acceleration. So he's using the same amount of force in both of these examples. But with the empty cart, because it has less mass, it accelerates much faster. It's much easier to push an empty basket. You go to the grocery store and you get that basket out and you're starting to grocery shop with your parents. That basket's sliding all over the place. But by the end, you're having to put your whole body behind it just to turn down aisles. At least that was me last night at the grocery store. When we add more mass, when mass is increased, but we keep force the same, the acceleration will decrease, meaning it won't move as fast. It won't change direction or its motion as easily. So the way we like to explain this is we use a formula. So like I said, the way we usually describe force equals mass times acceleration is by calculating it mathematically. So applying numbers to your pictures is a really helpful strategy. And when we were planning your test, that is something that I used to answer questions was I apply numbers, plug in different numbers to see the relationship between force, mass, and acceleration. Okay, so the first thing we want to do in understanding this formula is what does each of these letters mean? The F stands for force, M is mass, multiplied by acceleration. So force equals mass times acceleration. And then we have our pyramid or triangle, whatever you want to call it, that we used when we calculated distance, time, and speed. We are going to use this to calculate force as well. So force goes on the top. Okay, force equals mass times acceleration. Remind me, what does this line mean? This line underneath force? Okay. So this line also means divide. Okay, the vertical line means to multiply, and this horizontal line means to divide. So in this picture, we have acceleration equals. So a lot of times your questions, they won't always ask you for force. They'll ask you for acceleration. So it's really important to read the question and write down what's given so you know what you're looking for. So if we were looking for acceleration, the A is acceleration, we would divide force divided by mass, okay? If we went back to our triangle, force divided by mass, okay? And then another really important thing is the units. A lot of times it doesn't tell you the force is this and the mass is this. It just gives you numbers with units, okay? So I want you guys to tell me, what is the unit for force? Remember, guys, force is measured in newtons. Force is measured in newtons, and you guys should see that from your net force practice, okay? Mass. Mass is measured in grams or kilograms. You'll most frequently see kilograms. And acceleration. When you see meters per second squared, when you see that little bitty 2 by the meters per second squared is acceleration. Meters per second alone is speed. This little 2 tells you this is acceleration, okay? And that's really important. Okay, and so now we're going to flip it around again. Now we're looking for mass, okay? So mass equals force divided by acceleration. Just like our little triangle right here. Force divided by acceleration, okay? And then we need to apply our units again. Okay, so now we can practice this with an actual word problem. What net force is required to accelerate a car at a rate of 2 meters per second squared if a car has a mass of 3,000 kilograms? So the first thing we want to do is record what information is given. So what is the force? So what I want to do with this problem is I want to show you how to answer it with the triangle, okay? So again, we're looking for force, okay? But our mass was 3,000 kilograms. Okay, and our acceleration was 2 meters per second squared. So if we put this into our triangle, let me draw the triangle. The force goes on the top, so I'm just going to plug my numbers in. Mass was 3,000. And acceleration was 2. So this line tells me I need to multiply. Okay, so 3,000 times 2 is 6,000. Okay, what are my units for force? 6,000 newtons. Good, 6,000 newtons. Okay. So another step that she wants you to do is drag and drop the units to this formula. So force, we just said, was in newtons. Mass was in kilograms. And acceleration is meters per second squared. Now we can plug our numbers in. Okay, force again is what we're looking for. Mass was 3,000 kilograms times acceleration, which was 2 meters per second. So our answer was 6,000 newtons. Okay, so there were several steps that we went through in trying to practice identifying the information given to us and plugging that in to the formula. All right, so let's do another example. A 10-kilogram bowling ball would require what force to accelerate down an alleyway at a rate of 3 meters per second? So what is the force? Okay, we don't know the force. Now I need to know, is the 10 kilograms or the 3 meters per second squared my mass? Okay, so 10 kilograms is my mass. And that means 3 meters per second squared is my acceleration. Sorry, this is so rough. 3 meters per second squared. Okay, so now I need to plug that into my triangle. Force is on top, and that's what we don't know. Mass of 10 kilograms and an acceleration of 3 meters per second. So this line means to multiply what is my force. Good. 10 kilograms times 3 meters per second gives me 30, what's my unit? Newtons. 30 newtons. Good. 3, 0. Okay, let's do another example. Sally has a car that accelerates at 5 meters per second squared. If the car has a mass of 1,000 kilograms, how much force does the car produce? Okay, so they told us the words accelerate and mass. So it's very easy to plug in our information. Our acceleration is 5 meters per second squared. Our mass is 1,000 kilograms. And we're looking for the force. So I plug in my information into my pyramid. I have 1,000 kilograms multiplied by 5. So my force is 5,000 newtons. 1,000 multiplied by 5. 5,000 newtons. Okay. Okay, we have a little different of a question. Somebody said, what about the mass? Well, here we go. What is the mass of a falling rock if it produces 147 newtons? Okay, the acceleration of gravity is 9.8 meters per second squared. Okay, the mass of a falling rock produces 147 newtons. What the acceleration of gravity is 9.8 meters per second. So let's plug in our information. We have 147 newtons and an acceleration of 9.8 meters per second squared. So how do we find mass? We're going to find mass by dividing. Remember, this line means to divide. So 147 divided by 9.8 gives us a mass of 15. What's our unit? Kilograms. 15 kilograms. And this is our answer. All right, let's answer another one. What is the mass of a truck if it produces a force of 14,000 newtons? That's the force, 14,000 newtons, while accelerating at a rate of 5 meters per second. So our force is 1 for 14,000, and your acceleration is 5 meters per second. So we need to divide, and the answer is 2,800 kilograms. So when you divide 14,000, 14000, divided by 5, this means to divide, you get 2,800 kilograms. Put my unit. Very good. Let's answer one where we have to calculate acceleration. Okay? What is the acceleration of a softball if it has a mass of 0.5 kilograms and it hits the catcher's glove with a force of 25 newtons? So if we plug in our our numbers, which was the force, the 0.5 kilograms or the 25 newtons? My force is 25 newtons. We're looking for acceleration, and the mass was 0.5 kilograms. So we need to divide 25 newtons divided by 0.5 kilograms. And that gives us an acceleration of 50 meters per second squared. 50 meters per second squared. Acceleration is meters per second squared.